expression for equilibrium constant. Consider the reversible chemical reaction between reactants A and B, giving products C and D, represented by the given equation. AA plus BB, reversible reaction, giving CC plus DD, where lowercase a, b, c, and d are the stoichiometric coefficients of the balanced chemical equation. The equilibrium constant for a reversible chemical reaction at equilibrium is given by the ratio of the concentration of the products to the concentration of the reactants. Kc equals concentration of products over concentration of reactants. We shall now express Kc in terms of the concentration of each of the species. Let us denote the molar concentration, that is, in mole per decimeter cube, of the four species at equilibrium as square brackets A, square brackets B, square brackets C, and square brackets D. The square brackets denote that we are referring to the concentration of the species. The equilibrium constant for this reaction is given by the ratio of the product of the concentration of each of the product species, raised to its stoichiometric coefficient, to the product of the concentration of each of the reactant species, raised to its stoichiometric coefficient. Kc equals concentration of C to the power C times concentration of D to the power D, all over concentration of A to the power A times concentration of B to the power B. It is important to note that the exponents in the equation for Kc are the stoichiometric coefficients for the balanced chemical reaction. The equilibrium constant is unitless. However, the concentrations need to be expressed in mole per decimeter cube. There are some rules to follow for finding the value of Kc. The chemical equation must be balanced. The concentrations in the expression are the equilibrium concentrations, not the initial concentrations. The concentration of solids and pure liquids remain almost constant throughout the reaction and are ignored. Only the concentration of gases and aqueous ions are used in the expression. Let us find the expression for Kc of the reaction. N2 gas plus 3H2 gas, reversible reaction giving 2NH3 gas. The equation is balanced. Here, all the chemical species are gases, so we use all their concentrations in the expression. Kc equals concentration of NH3 to the power 2 over concentration of N2 times concentration of H2 to the power 3. Let us find the expression for Kc of the reaction, where magnesium is used to reduce titanium chloride to titanium metal. TiCl4 gas plus 2Mg liquid, reversible reaction giving Ti solid plus 2MgCl2 liquid. The equation is balanced. Here, the only gaseous species is TiCl4. The others are solids or liquids. Therefore, we only use the concentration of TiCl4 in the expression for Kc. Kc equals 1 over concentration of TiCl4. This reaction is used in the production of titanium metal, used in aircrafts.
Starting to feel it? Now go master it with Maski.